Hi everyone, it's Mosiah here. I am one of the member of Group 2, and my group are consist of 4 people, which are Mosiah, myself, Balkis, Marwa, and Nadia. So today we're going to be talking about precision, accuracy, error, and uncertainties. It would be very much appreciated if you pay attention to these slides, and we really hope that these slides are very understandable. So let's just start.
Whenever you make a measurement, you are trying to find the true value of a quantity. This is the value you will find if your measurement was perfect. However, no measurement can ever be perfect. There will always be some uncertainty. Your equipment may be imperfect or your technique may be capable of improvement. So, what are the things you have to think when it comes to this? Here are the 2 things. First, how the equipment or your technique could be improved to better results with less uncertainty. Last, how to present the uncertainty in your findings. What happens if the measurement is precise? The level of precision is high if you make several measurements of a quantity and they are all very similar. A precise measurement, when repeated, will be the same or nearly so. However, if your measurements are spread widely around the average, they are less precise. This can arise because of practical difficulties in making the measurements. Can you be more clear?
Okay, here's an example. Whenever you make a measurement, you should be aware of the uncertainty in the measurement. It will often, but not always, be determined by the smallest division on the measuring instrument. On a meter ruler which is graduated in millimeters, we should be able to read to the nearest half millimeter. But beware, if we are measuring the length of a rod, there are 2 readings to be taken, one at each end of the rod. Each of these readings has an uncertainty of 0.5 millimeters, giving a total of uncertainty of 1 millimeter. Is there any examples where uncertainties might arise? Of course, here's one example. Random errors. When a judgment has to be made by the observer, a measurement will sometimes be above and sometimes below the true value. Random errors can be reduced by making multiple measurements and averaging the result. Good equipment and good technique will reduce the uncertainties introduced, but difficulties and judgments in making observations will limit the precision of your measurements. So how does the difficulties in observation will determine the uncertainty in your measurement?
Example 1. Using a stopwatch, Tombo has a digital stopwatch which measures to the nearest 100th of a second. He is timing Nana in a 100-meter race. He shows her the stopwatch, which read 11.87 seconds. She records in her notebook the time 11.9 seconds. She explained to Tombo that he cannot possibly measure to the nearest 100th of a second as he has to judge both when the starting pistol was fired and the exact moment at which she crossed the finishing line. To do this to any closer than the nearest 1/10 of a second is impossible. In addition, sometimes he will press the button too early and sometimes too late. And how do you estimate the uncertainty in your reading without knowing the true value? Obviously, if a reading is 21.5 cm and you know the true value is 21.0 cm, the uncertainty in the reading is 0.5 cm. However, you may still have to estimate the uncertainty in your reading without knowing the true value. And how is it done?
First, it should be understood that the uncertainty is only an estimate of the difference between the actual reading and the true value. We should not feel too worried if the difference between a single measurement and the true value is as much as twice the uncertainty. Because it is an estimate, the uncertainty is likely to be given to only one significant figure. For example, rewrite the uncertainty as 0.5 cm and not 0.50 cm. How can the uncertainties be estimated? The first thing that the uncertainties can be estimated is by using the division on the scale. Look at the smallest division on the scale used for the reading. You then have to decide whether you can read the scale to better than the smallest division. The second answer is by repeating the readings. Repeat the reading several times. The uncertainty can then be taken as half of the range of the values obtained. In other words, the smallest reading is subtracted from the largest, and the result is half. This method deals with random errors made in the readings, but does not account for systematic errors. Thank you. Bye.